Okay, we will start back up in a minute or two. As with everything I've said, if you're having problems getting on or accessing the system or have any questions, please do let me know. Okay, so as previously discussed, what we're going to look at today really is scheduling and debugging and profiling, and that should take us through to some time between 3 and 4 o'clock, where we'll break for the day and come back. And tomorrow we'll do how to begin ARCHER2 Citizen using safe, next steps for the first hour, hour and a half, 10 o'clock on tomorrow. And then beyond that, there is a example where you can run a application we provide to just get some experience using the system, or you can take the rest of the time to go on and play with your own applications on the system with people around to ask questions. So myself, I'll be around in the session till 4 o'clock tomorrow anyway. If there's anybody with any questions or any things they want to chat about. So that's the idea tomorrow. Most of tomorrow is just a chance for you to play with the system. But we do have a couple of things to go through which are useful things to know, I think. Just now, what we're going to have a look at is we've looked at the development environment, so you should now hopefully have a little bit of a feel for the compilers that are available on Archer and the other software that's there, or at least be able to find out what other software is there. These module systems. The other important part of using a system like ARCHER2 is the batch system and the scheduler. So how can you get your applications running on the compute nodes? So what we're going to do is go through, discuss what the setup is and how you use it, and some of the other things you may want to know. And this is one of the places where ARCHER2 is quite different from Archer, in the sense we're using a completely different scheduler. The concepts are all the same, but we're using Slurm instead of PBS. And that means that we've got a whole new set of commands to use, and we have a whole new set of things to put into our job script. So our batch scripts are going to be different. It also means we've configured the system in a slightly different way, or at least from a user perspective, you get a slightly different view of the system. So ARCHER2 uses Slurm as the batch system and the scheduler. And those two things are slightly different, but you don't need to care about it. But effectively, the batch system is the overall system which takes jobs and interacts with the user, and then the scheduler is the thing which decides which of those jobs is being given to run when. And these two things can be run by different bits of software, but in ARCHER2 using Slurm to do both of them. And just like with the Archer system, there's a key set of commands which you need for interacting with the scheduler, and to submit jobs, to find out the state of your jobs, to find out the state of the system, and to generally interact with those compute nodes. Now, actually, I haven't put a table in here, which I might do after this, comparing ARCHER2 to Archer. Effectively, these are all very similar commands to we had on Archer, but they've got different names and slightly different characteristics. So we have Sinfo, Slurm info, which queries the current state of compute nodes. SBatch, which is to submit a job to the scheduler. Non-interactive, so this is to submit a batch job, something that it will run for you later. SQ will tell you a list of all the jobs that are running, not running, waiting, those kind of things. SCancel will let you cancel a job you've submitted, whether it's running or not. And then these two are slightly different and a bit of a departure from Archer. We have salloc, which lets you submit interactive jobs. And we have srun, which also lets you submit interactive jobs, is also the job launcher we have on ARCHER2. So slightly annoying, but Slurm is a little bit overloaded in the commands it uses, in that some of them can do different things in different contexts. If you are an Archer user, this command here, sq, is the same as qstat on Archer. scancel is the same command as qdel. sbatch is the same as qsub. Sinfo is something more like PBS nodes or qstat minus capital Q or something like that on Archer. But I mean, that's slightly different from what you get on Archer anyway. And then srun inside a batch script, which we'll come on to see, is the same as ap run on Archer. So it's the job launcher which starts your parallel program inside your batch script. But annoyingly, Slurm also overrides this, so it can also submit a job from a command line, an interactive job from a command line, or you can do that with salloc. The Slurm is slightly confusing in that there's a couple of different ways you can do an interactive job. And for those of you who are novices at this kind of thing, an interactive job is a job where you get access effectively to the compute nodes and you can run your commands there yourself manually, as opposed to a batch job where you put all the things you want to run inside a script and submit that, and then that gets run at a later date, but you never actually touch the resources yourself. And interactive jobs are not a large part of what we would do on something like Archer or ARCHER2, but they can be useful in things like debugging why things are not working and testing out little bits and pieces. You wouldn't expect to really do an interactive job on hundreds of nodes, but you may want to take a 5-minute interactive job to just try and see what's going wrong with. So we'll come and discuss the complexity here, but people do get a bit confused because you can call srun from the login nodes and it does something different from what srun does when inside a batch script, and that's just the way of Slurm is. There's a lot of Slurm documentation out on the web, including this running jobs on ARCHER2, which is effectively what we're going to go through now, and also the some more details in the quick start for users as well. So there's a lot out there anyway. Go and have a look at this in a bit more detail. Here's an example of what you can do. So sinfo will tell you the state of a system. And actually, this is an sinfo which I ran earlier today. And it's a little bit long, unfortunately a little bit messy, because it prints out all the IDs of the nodes that it's telling you about. So there's a couple of things we can see here. It's by default telling us what partition something is running in, whether that partition is available or that set of nodes is available, the maximum time limit of that partition, how many nodes are in this current state, and which of those nodes. And most of this you don't care about, but a lot of this is sort of representative of some of the ways the system is configured. What we can see here at the moment, or when I ran this snapshot sinfo earlier today, 60 nodes were down. That means they're broken in some way and taken out of the system. 11 nodes have been drained, which means they've been taken out of the system, but actually they're still up and running. The batch system can talk to it, but they're not active for user jobs. 5 nodes have been reserved. These are actually generally used for the short queue, which we'll talk about. 565 nodes are up and running and have been used by applications, by people, so they're allocated, and 380 nodes are idle, so sitting there waiting for work to do. Now this is an unusual state for us. You would normally expect this number of idle nodes to be much lower, but we're in an early user phase, early access phase, so we don't have many users on. Up until yesterday, we only had 20 users on the system. Today, we've got all you guys, all you people, and probably another 60 users coming on as well, so it's going to get a bit busier. And then come some point over the next couple of weeks, all the Archer users can start porting over. So we wouldn't expect to see large numbers of idle nodes over time. But this is what the system looked like this morning. Now you don't really care about all which nodes these are, but it just shows you that we have a whole bunch of nodes. You know, this plus 380 plus 560 plus 5 plus 11 plus 60 should add up to 1024, because that's the number of nodes we have in the system. And hopefully over time the number that are down and drained will reduce, so we don't have so many taken out of production. But that's the state of the system at the moment. I should have updated this here. The first thing that is different from something like the schedule we have on Archer PBS is this idea of partitions, and these can be thought of as queues. Partitions are something that we have defined when we set up the system, and they are placed to put in groups of nodes, categories of nodes. Actually, if you want a bit more detail about this, I gave an ARCHER2 virtual tutorial on the batch system a couple of weeks ago, possibly last week, which is online and recorded. So if you do want more detail on that, you can go and watch a whole hour of me talking about the learn batch systems. I'm not sure you'll thank me for it, but it's definitely, there's a bit more detail we go through there than we are planning to go through today. But the partitions that we are so we have these standard partitions, and that's quite different from what it looked like on the ARCHER2 system. At the moment, on the ARCHER system, at the moment we only have a standard partition. There's only one partition. All the nodes are in the same place. All the 1024 nodes are in the same place. When we come to the future ARCHER2 system, the full system in next year, early next year at some point, when we get the high memory nodes, we will get a second partition for them called high mem, I think. We don't have that at the moment, but that means if you are, if you want your nodes to guarantee, your jobs to be guaranteed to run on these nodes with 512 gigabytes of memory, not 256 gigabytes, you would submit to the high mem partition and not the standard one. But at the moment, we only have one partition, and it's the same for all nodes. We also may have in the future a GPU partition, because we're going to have a small number of GPU nodes in the system, which of course are different again, and so they may be in a separate partition. So the partitions are where you group together nodes with different characteristics, and at the moment we just have the standard one. Okay. It's worth pointing out that even though we may split up the standard and high memory nodes into different partitions, actually we will set them up in such a way where if nobody's submitting jobs to the high memory partition, those nodes can still be used by the standard partition. So effectively, you add all the nodes into a standard partition, apart from the GPU ones, because they're different. And then you create another partition with the high memory nodes in again, so that if you want to submit jobs just to the high memory nodes, you submit to that partition. If you want to submit jobs to any nodes, you don't care if they're high memory or not, you can submit to the standard partition and it'll go to one or the other set of nodes. And that's important for us because that lets us be able to have these different kinds of hardware nodes in the system, but still potentially run a job that uses them all. It can go across all 5,800 nodes, even if some are high memory, some are not. If we physically split them up into two partitions and you had to submit to both, then you don't have that potential to run across the whole system. And you start to get a little bit of inefficiencies in your scheduler. The more you split up your resources, the more overhead or sort of lack of utilization you can get in the scheduling. So that's what we'll do. And then the other things here, available, you don't need to care about. Time limit is the maximum runtime that a job can operate, can be submitted for in the partition we're looking at. And we can see here the standard partition has a time limit of 2 days, 48 hours. So that's the maximum job you can run on Archer by default. As we'll come on to talk about, there are actually different ways of submitting the jobs using what's called quality of service configurations rather than partitions, where some jobs you can run for 24 hours and some jobs you can run up to 48 hours and something in between. By default, for partition, a 2-day time limit on. If you ever wanted to run jobs that were longer than 2 days, and we don't let people do that by default on Archer, because again, that starts to impact scheduling of fairness of scheduling of people's jobs and resource allocation. There will be in the future ways to request reservations where you can say, actually, can I pay for 100 nodes for a week in a reservation, and that was set up in advance, and you can use it like that. So that will be possible. We don't have the reservation. We don't have a reservation set up like that. Yet. And actually, on the original Archer system, the current Archer system, we have quite a nice system where you can submit your own reservations, but Slurm doesn't give you that, so we have to go through the help desk. So Gavin's asking a great question: why does 1 minus 0.00000 represent 2 days and not 48 hours? And that's a Slurm thing. So the hours, minutes, and seconds here go up to 24 hours, and then beyond that, it goes into days. So effectively, you're saying 1 day plus a full 24-hour period. It's just how Slurm does it, I'm afraid. It doesn't count in hours, it counts in minutes, seconds, minutes, hours, and then days. So once you overflow the hours, you go into days. Okay, I mean, this is more detail than you need most of the time, but that's what it is there. Yeah. So you see days, hours, minutes, seconds. Then number of nodes, state will be down, drained, reserved, allocated, idle. So this is just for nodes. Either the nodes are allocated or they're idle, either they're busy or they're empty. And a list of nodes in those states which you don't care about. Okay? And nodes can be idle, allocated, draining, which means something's gone wrong with a node or someone's taken them out, down, failed, reserved, or in maintenance mode. Actually, all again you care about probably is idle and allocated. Which jobs are empty and which jobs are full. You can actually have a look at the individual node state if you care about it using this incarnation of the sinfo command. Sinfo minus capital N minus L, and you get the output of every single node with its state. And here it prints out a default set of information. So it's saying, this node here is in standard partition, it's idle, it's got 256 CPUs. We'll come back to why it's got 256. 2 sockets, 64 cores, 2 threads. It's got 256 gigabytes of memory, although it says 244046. That's 256 gigabytes of memory. It's got no temporary disk. Its weight is 1, which you don't care about, and it's got no reason here. So you can see, actually, look at the configuration. Once we have the large nodes in there as well, the large memory nodes, this would look exactly the same, but some of the nodes would have a different value in here for memory. Now, at the beginning, in the first lecture, I said, well, Archer's got this, the ARCHER2 system at the moment, it's got 1,024 nodes. Each node has 2 processors, each with 64 cores. So it's got 128 cores per node. And that is correct. It's got 128 physical cores per node. But Slurm here is saying it's got 256 cores per node. What's that about? And that's because on these AMD processors, each physical core can run 2 hyperthreads. It's designed to run 2 hyperthreads. So you can run up to 256 processors per node or threads per node. And the batch system knows about that. So it's saying, actually, I can see 256 things I call CPUs. It's a very overloaded term, but 256 CPUs per node. And that's 2 sockets, 64 cores in each socket, 2 threads on each socket, on each core. And so that I can actually run up to 256 if I want. This was actually true on the current Archer system, where normally there's 24 cores per node, but you can run in hyperthreading mode where you get 48 threads per node. And that's the same here, except they're enabled by default. You can also take this, so just to give you an idea of playing around with Slurm and the Slurm batch system, you can have a look. It generally lets you because the commands are pretty verbose and they can tell you lots of information, it generally lets you specify formats to print you out information. So I can do sinfo, give it the name of a node, and then say put my output format and give me the number of CPUs, cores, and memory per node or something like that, and that will let you look at these nodes individually. Now, most of the time you don't care about this. I care about this because I do work looking after the system sometimes, but most of the time you don't care about this at all. But it's just to give you an example of playing around with this kind of information. And if we had the high memory nodes in the system, we could say, can you use sinfo to find out which nodes have the high memory nodes in the system? And you could use a command like this. This was an example where we had a test system where we had 4 high memory nodes and 4 non-high memory nodes before we got this 4 cabinet system. And so you could say, tell me which ones have a memory, print out all the nodes and tell me what their memory is. And then you can have a look and see what's going on there. So that's just to give you an idea of playing around with. Because we don't have those high memory nodes, I put in a different kind of problem here you could play around with. The question here is, it's also possible to search nodes by state. Can you find all the free nodes in the system? So here, sinfo minus capital M minus L will tell you information on all the nodes in the system. But I want you to find the ones which are in the idle state. So can you devise an sinfo command, which will tell me, just give you the list of the nodes that are in the idle state? And this is just to give you a little playing around with Slurm on the system, but to show you how you would go about doing that, and then I'll let you go and do it. Let me share my screen, my terminal. Try that one. Yes, okay. And now hopefully you're all logged into the system and you have a command prompt like this. Sinfo is a command you can use, which I've just been talking about. But you don't know, I'm imagining, how you search by state. So what we can do is use this command man sinfo, and it tells me all the options that I can pass to sinfo to tell me different things. So I can say, tell me all the dead nodes, display all the nodes, those kind of things. And what I would like you to do is look through this man page and see if you can find a solution where you can specify the state of the nodes and look for the ones which mean that they're empty, and see if you can get that list. And I'll give you a couple of minutes to do that, and then we'll continue the lecture. That's absolutely, Alexei. sinfo minus L grep idle would do it. But there's a way of doing it where you pass in you ask the sinfo for a specific state, passing in a command to, an argument to sinfo. So if you can find that as well, then that would be interesting. But definitely, yes, you are right. So if I did sinfo minus L, grep idle will tell me the idle ones. Likewise, if I did that with capital N to show me the individual nodes, that will do that as well. But there is a way of not having to use grep. You get a list here where you just get the idle nodes out, and that's what I'm interested in. But yours is a great. Okay, hopefully you've all had a little chance to play around with the sinfo command. Now I'll expose my ignorance here because it won't work. The answer should be, I think. I'll get this wrong here. Yeah, okay, that's right. You can actually specify this parameter minus state and just say idle, and then it will just give you the nodes that are all idle here. Or actually, you can do a minus t, I think, the same way. But of course, use minus t, you need to do it in a different way. So minus t is idle, or minus state equals idle. They both do the same thing. Now, I'm not really showing you this because I think it's going to be particularly useful to you. It's more just to show you that the slurm commands are generally quite configurable, and if you have a look around in the manual pages or online, there's a lot of the manual pages are pretty much reproduced on the slurm website. You can find out how to do what you want in there, particularly the output format is quite often commonly used in a lot of the commands to try and get a bit more information out of, and you can generally pick up different fields that you want here. So all these different things you can display number of CPUs per node, free memory per node. This is just for Sinfo groups which may use the node. None of these things are shown by default. You can tell it to tell you those if you want to. List of node communication addresses. I don't know what that will do on Archer actually. ARCHER2, sorry. So if I said equals, it's just telling me their communication address. Okay, it's just telling me their host name. So there's a whole set of things that you can generally get from Slurm, which it doesn't tell you by default. The username of who set the node reason is unavailable. The name of the user who set the reason is and the UID. So you can use generally query Slurm for quite a lot of information that's not told to you. But we'll see a little bit more of that as we go on. Right, I'll stop sharing that now and start back onto the walkthrough. So hopefully that is correct. Yeah. Okay. And that's just telling you what state the system's in. That's not that useful for you. What would be useful is to be able to submit jobs to a batch system so they can take advantage of those idle nodes. And so here we have an example, and there are good examples in the Archer online document, ARCHER2 online documentation as well. We have an example of a batch script to run a simple program. Here actually we're using this XTHI program, which originally was developed by Cray, to let you investigate how processes and threads are assigned to cores and hyperthreads and check your binding and these kind of things. A little MPI and OpenMP program. And we've got a batch job here. So we can see here that this is, again, if you're used to Archer, it looks different. We're using #sbatch here instead of #PBS. And then we have a whole set of parameters that we need to pass into our batch script here. And so this defines what job I'm going to run and how I'm going to run it. And then down here, we can see we've got the job launcher. Let's run in this example, which would have been like AP run on the original Arch system, and then the name of the executable. And I've put something special in here called CPU bind equals cores, and this we'll come on to see is useful in making sure that we get our processes that we run in the right places to exploit those NUMA regions and local memory and these kind of things. Okay, what are these parameters that I would need to pass into a batch script? Well, they're very similar to any batch script I have to write. I can give my batch script a name. So that's when I look in the queue, I can get the I can identify which is my batch script, but I don't have to do that. I tell it how many nodes I want. On an Archer, node use is exclusive. The minimum I can ask for is one node, and I can ask for multiple nodes at a time. So I can ask for 1024 nodes or one node or anything in between. I can't ask for one node and then two processes from another node. That's not how it works. We effectively give exclusive access to nodes to each individual job. And then I can specify, now I don't have to do these two lines here, 10 tasks per node and CPUs per task. But this helps Slurm work out how many things I want to run and how I want to put it on. Do I want to use the hyperthreads or not? Do I want to spread the things I'm running across the node or put them in one place? So this is good practice. So I tell it I want to run 128 things, so use all the physical cores. Each physical core has got one thing on it. I'm going to run for at most 10 minutes. I'm wanting to submit to the standard partition, and as we've already said, there is only one standard partition. That's what all we'll use for now. And I want to submit with a standard quality of service setting. And actually, I don't think we're discussing here, but there are multiple different quality of service things that we can have on ARCHER2 at the moment, and then potentially more in the future. But at the moment, we have the idea of standard, and a standard QoS means I can run up to 24 hours. So that job can run up to 24 hours long. It can't go up to 48 hours. It can only run up to 24. And I can run from one node all the way up to 1,024 nodes on this system. So standard lets me use the whole system for up to 24 hours. I also have some limits on that, so I can only submit 16 jobs. So I can only have 16 jobs running at any one time, and I can have another 16 jobs sitting waiting to run in the queue. And that's it. So I can have a total 32 jobs submitted to standard partition. That's standard QoS. There's also another one called long. So instead of having QoS equals standard here, I would change standard to long. And that lets me run jobs which are between 24 hours and 48 hours long. I can't run shorter jobs than 24 hours using that QoS, but I can run between 24 and 48 hours. And there we have some different limits. You can only use up to 64 nodes per user. And it's slightly complicated, but you can submit, I think, as many jobs as you want to that. You can only ever use 64 nodes. You only ever use 64 nodes. And actually, in total, only half the system, only 512 nodes can be used in long. So if you submit a job on queue and other people are already using quite a lot of it, it may sit and wait for a while because in total, only 512 nodes of a whole system can be in the long format. And then finally, we have a short one as well. And that's a sort of debug queue, which lets us run small jobs quickly. So the short queue, you can run jobs up to 20 minutes long, up to 4 nodes. At the moment, you can have one running job and 2 jobs in the queue. And this short queue is only available between 8 in the morning and 8 at night, Monday to Friday. It actually depends on a reservation, so you have to submit it using a reservation as well, which I've not put in here, but I can put into the chat once we've talked about how you do actual batch submissions. So again, the partition just defines the set of nodes I can go to, and then the quality of service defines what kind of job I'm running there. Is it a long job? Is it a normal job? How many of these kinds of jobs can I use? Is it a short job? These kind of things. So it's sort of specifying the limits on the job there. And then I load the module because that's where this executable is. I tell it how many OpenMP threads I have. If you're not running an OpenMP program, it doesn't matter. Then you can do srun. And this will actually, interestingly enough, you can see here, I'm not telling srun how many processes to create, how many times to copy this and run it. Because srun is picking up number of tasks per node and number of nodes up here and saying, okay, you asked for 2 nodes, you want 128 tasks per node. Okay, down here, I'm going to run 256 tasks, and I'll get an MPI job here running with 256 processes. I don't have to tell srun down here what I want to use. Now, I can do. The thing is, I can have multiple srun commands in the same batch script. So I could run 3 of these at once and tell them each only to run 96 cores and pass in a -n here, srun -n 96. And then I could have them all free running on different nodes, actually sharing resources across nodes, and Slurm will quite happily. But by default, if you've got a single srun command and you've specified the number of nodes and the number of tasks per node, an srun will just launch your job on all the tasks, the tasks you've asked for, 156 in this case. And then I am submitting on a standard account here, so I'm telling it what budget to charge against. Now, when your account gets created, it gets given a default standard budget, so you can omit this line and your job will still run. But generally, it's good practice to put this in because you may have multiple account budgets that you can use for the same account, and you want to make sure you're charging it to the right budget. And the budgets are the things that tell you how much time you have on the system. So that we can make sure that people don't use more time than have been allocated. Any questions about that?
Yes, Adrian. Can you hear me?
Definitely can.
Very good. Options here: CPUs per task equals 1. You say number of cores to allocate per parallel process. Do you mean number of threads?
No, so Slim is slightly confusing in this context as well. In this context, it means physical cores. The way we set it up, it means physical cores. And that's because if we go back up to this thing here, where we looked at how the nodes are configured, Slurm actually knows that you have 2 sockets per node, 64 cores per socket, and then 2 threads per core. And so when it says, even though it says here CPUs is 256, when SBatch says CPUs per task down here, it means cores, annoyingly. So that it knows the physical number of cores in the system because when we configured the batch system, we told it the physical number of cores. And then we told it we had threads. And then because down here we've said CPU bind equals cores, it says, okay, 1 task per core, bind it to the cores. That means bind it to the physical cores, don't go up to the hyperthreads, and this will just all go on the physical cores. That makes sense?
I'm sure it will over time, yes.
So I understand the question, and it is absolutely a slightly confusing thing here. If I put 256 here for number of tasks per node, and then I'd have run like this, it would have complained to me because it would have said, you're trying to bind to cores, but you're asking for more things than there are physical cores on the nodes, so something's gone wrong here. And then I can change my CPU bind options down here to threads, and then it will bind to each hyperthread, and then I can use it. So it gets a bit complicated. But by default, for just a plain MPI task, you can do this. It will just use the physical cores, and it will ignore the hyperthreads on the nodes. That's what it will do. And indeed, you can underpopulate this, and you could say, actually, I don't want 128 tasks per node. I only want 32 tasks per node. Give me 4 CPUs per task and bind to the cores. And it would use every 4th physical core and still ignore the hyperthreads. Make sense?
Yes, it does.
What we will do, hopefully, is we'll play a little bit with this program, and you can mess about with these parameters and see what it actually does, because this program will print out, okay, my process was running on this core, and this thread was running on that core, and you can then have a look at it. Any other questions? Thanks, Gavin. So once you've got that batch script, you can then submit it using SBatch. So assuming that I had called this script here, the script that I've typed into a file here, if I'd called it testjob.slurm, and you don't have to call it .slurm, right? You can call it whatever you want. You have to call it testjob, just a file name. I then do sbatch, file name, and I get a prompt back which says submitted batch job, and here's your number. A couple of things to remember here. This here is incorrect, only because this has actually been submitted from the whole home file system, and if you do this, your job will submit, but you won't get any output. You should always be on the work file system, if you remember, unless you do some very fancy things, which we've not told you in here. where you specify exactly where the directory you're running from is, and where your output file should go and where your input file should go. Sorry, where your output file and your error file should go, which you can do, but you have to add extra options into the SBatch here. You'll get a silent failure at this. In fact, it's not a failure. The job runs, it completes, you don't get any output because it could never find the place to put the output, and that's sort of not what you want. The other thing is that this batch script will run from where you submit it. So, I've not put any CD command in there. I've not said go into a particular directory. So if I submit it from a directory, that's where it will run. Again, that has to be on the work file system. Yeah, and so once you've submitted that job, you can then check its status and things, and we'll have a look at that in the SQ section. There are good questions here. So if you do not specify job options, what are the defaults on Slurm on ARCHER2? Submit jobs to find out what the defaults are for budget, tasks per node, number of nodes, and wall time. And so this is a little bit hard to ask you to do, but what we can do, what I would like you to do, is take this batch script here, copy and paste it into a batch script on ARCHER2, and then what you can do is change this to one node. You don't need two nodes to do it. Change it to one node to start with, and then try commenting out this line here in tasks per node and submitting it. We'll submit it like this to start with, see what output you get. And then comment this line out here and run it and see what output you get. And that will let you know what task per node. I think I've already answered this for you, unfortunately. If you don't specify a count, a default one will be used, but it won't tell you which one that is. And then you can have a look at, if you don't specify the number of nodes, what will it do? And if you don't specify the wall time, what will it do? And you can tell that actually once you've submitted the job, because if you do something we've not talked about yet, but you can jump ahead slightly here. Let me share my terminal again. This one. If you use this command SQ here, well, maybe it won't tell you. I thought it would tell you in the SQ command how long your application would run for in this time section. Okay, right. The next that question is hard, and there is a way of finding out how long a job has been submitted for using SQ, but we haven't told you how to do that yet. So if you want to jump ahead and look at that, that's perfectly fine. But don't worry about that. So really, all I'm asking you to look at to start with is what happens if you don't specify number of tasks per node. What happens if you don't specify number of nodes? Really, I just want to get you to get a feel for writing a batch script, submitting it, getting some results back. Remembering that you need to be on the work file system to get this to give you sensible results. And if you don't know where the work file system is for your account, just type in the chat and I can tell you, type me your username in the chat and I can tell you where your work file system is. So give that a shot for a couple of minutes and then we'll come back and move on, and I will let you know the answers if you're not quite there yet. And if you finish early before I start speaking, you can let me know as well and we can move on. Normally I would do this as in a software carpentry style way where we have sticky notes and you can tell me when you're finished by putting up a green sticky note, and you can put a red sticky note up if you're having problems. But of course we've not got any of that functionality easily to hand here, so just let me know in the chat, a private auto room, that's fine. Any questions? Okay, interesting error. Is that from running the XTHI application?
No, it's look, I just built it using the Cray Fortran compiler. Sorry, no, XTHI works fine, and it defaults by the way just sorry, am I supposed to say it?
Is this one of your own applications then?
Exactly.
Okay,
Sorry.
I will put a command in here. You may have to add. Let me try it. Put it into the chat. Alexa, that's this add this module restore etc cray ped program of cray into your batch script. If you're not using the cray programming environment, if you're using the GNU one, change cray to GNU, and if you're using the AOCC one, change cray to AOCC. This is something which we're still trying to get right on the system, how these are configured. So this may change over the next few days, small amount of time, weeks maybe, and you may not have to do this module restore inside the batch script anymore, but that may be necessary for what you're doing here. So try that, and if it doesn't work, let me know. Well, the other thing I should say is that this default script I'm giving you here should work for anybody who's using an account which has been created for this training project, where you've got the account for the training project, this TA004. If you're using an account from a different project, if you've already got an ARCHER2 account and you haven't signed up for the training one, you'd have to change TA004 to something else on that. So if I know a small number of people already have an account, so using those instead. If you get an error which looks like invalid account or account partition combination specified, like I just did, and that's why you'd need to change which account you're specifying. Okay, hopefully you've had a little bit of time to play with the options, and we should hopefully now be able to say what the default number of tasks per node is if you omit to specify it, and the default number of nodes, because this XTHI program will just, in the way we've set it up in this configuration, just spawn as many tasks as the batch system will let it, and then tell you how many tasks it's created. So if I take this in reverse order, if we don't specify the number of nodes, then we should get one node. That's the default. You don't specify, you get one node. If that's not what you wanted, unfortunately, you have to specify something different. If we don't specify the number of tasks per node, it should give us 256 tasks. You should try and use all the resources in the node. That's what Slurm does. It knows it has these hyperthreads and these cores and these sockets. It's going to try and use them. So if you don't specify a number of tasks per node, it will go up to 256. But by default, a job where you specify neither the number of nodes nor the number of tasks will run 256 copies of your program on a single node. So that's why it's useful to specify these things, because those may not be defaults that you're particularly interested in. You can find out. Let me remember how you do this. There's a way to find out what your default account is on ARCHER2, and so if you don't specify what your account is, there will be a way to find out what your default account is. And actually, that's going to be using another Slurm command, which we haven't looked into yet, called xAccount Manager. So let me just see if I can find my. Remember how to do this. So I think by default, if you do account manager show user and then your username, that will tell you what your default account is. So let me share my screen to show you that. And that sort of defines this first one, what budget or account is the jobs charged if you don't specify it. If I stop sharing here, I go over here. So on Archers, we had this quite nice little command called budgets, which would tell you what budgets you had access to. Slurm doesn't quite work in the same way. But we have these as account manager commands here. So it's another Slurm command called as account manager. I can say show user, and that's my username, and it says user Adrian J has a default count of Y07. So if I don't specify this run XTCI what account I want to charge to, and I try and submit my job, something goes wrong here. So it says, we can ignore this bit here, it says error, associate max CPU minutes per job limit, dispatch error, batch job submission failed, job violate accounting QoS policy, job submit limit, user size, and or time limits. And so what this is telling me actually is my default budget is Y07, but Y07 doesn't actually have any time in it. If I try and submit to that, the batch system won't let me submit, and it'll say actually you've got something wrong there. Whereas if I change my account to Z19, which is what project this user account is in, it's perfectly happy. And that's how you can find out what you would submit to this S account manager, show user, and then your username. There's also other things you can find out there. I can't remember. Yeah, so you can also find out which budgets you're in completely. So that's only telling me what my default one is. I can do this S account manager show association where user equals username, which is nowhere near as nice as the budgets command we had. You can see here that I have my account, S account manager, show the associations where my username is Adrian J, and I can see my account is being associated to 3 different budgets, one called CSE admin, one called Y07, and one called Z19. And importantly, this is wrapped around the screen, so this is slightly nasty. I can probably do a format so I can make this look a little bit nicer, so that I can say only show me things I care about. And what we can see here is that 2 of these accounts have this special flag set in max T-res mins where CPU equals 0, CPU equals 0. And then this Z19 one down here has nothing set in it. It's about what that says is here these 2 accounts have been disabled because they've got no time in them. And this account here is fine to run because it's got time in it. That's all we get on this system. Now I can check actual budget usage going through the safe tool and see how many actual hours I have. But what I can tell on the system is this one's allowed to run jobs and these 2 aren't allowed to run jobs because they don't have any time in them. Any questions about that? Now the final question was, oh yeah, carry on, Karen.
Did you say that you could see how much you have left in your budget using S Account Manager?
No, you can see whether you have anything left in your budget or not, but you can't see how much you have left. You can't see the actual time in the budgets on the system anymore. We can only see it through Safe now, so you have to log into Safe and have a look there.
Okay, thanks.
No worries. Apologies. So that was. I would like to say that was a technical problem, but I forgot to press the switch my microphone back on button. So I was just saying there is that should be everything you need to do to submit a job. There's quite a lot you can do with specifying different numbers of configurations of processes and threads per node. That's what you want to do. As I said, if you want to run on different numbers of longer than 24 hours, you'd need to use different QoS setting there. If you wanted to run on the short queue, you'd need a different thing there. But in general, that's what you need to submit in that application. An SQ will then tell you what jobs are running. And if you type SQ now on the system, hopefully you can see that there's a reasonable number of jobs running on the system. And somewhere, you know, there's a, actually, if you have a look, there's a few jobs waiting to run in the PD state, that's pending. Actually, there's a 1024 node job waiting to run, and that'll wait a while because we don't have 1024 nodes up and running at the moment. Some are down. And there's some jobs that have been running for nearly 20 hours. The rest, you know, smaller numbers of nodes, smaller amounts of time. So you can see what's going on the system at the moment. You can also cancel a job if you want to. Stop it run. If you submitted it but you don't actually want it to run anymore, you can use scancel. Just scancel and then the number you got when you submitted the job. And so if I wanted to kill a job out, be scancel, and then the number of the job that's running or waiting in the queue will stop it running. Will stop it being queued. You can, just like with PBS on the normal Archer system, you can get Slurm to email you when your job starts, ends, and those kind of things. And I'm not going to ask you to do this. You can use this mail type parameter for the batch system to say, please submit me please send me an email when my job finishes or if it fails. And you can also get it to send you an email when jobs get close to running out of time. So time limit 50, time limit 80, time limit 90. Tell me when my job is nearly at the end of the time limit or halfway through. And so that may be useful for you to let jobs, submit them to the queue and run. And you can also get it to tell you when the job started as well. So that may be something of use to your development flow and keeping you informed of what's going on in the system. And then inside the script, we've also should have noticed that we're using this srun command to launch our job, running the parallel application. And the job launcher sets up the job and effectively copies it to large numbers to all the places it needs to run, and does all that kind of configuration for you. That would be AP run on Archer, but on ARCHER2 we're using srun. And the nice thing actually on ARCHER2 is there's much more scope for sharing nodes inside a single job. So you can, on Archer, you know, each node had to really, unless you use some special programs to get around it, each node had to really be used by a single application when it was running. Whereas on Slurm, on ARCHER2, we have this chance to run more complicated jobs, sharing nodes between different applications, as long as it's all inside the same batch script, inside the same batch job, then that will work. And the srun here is the thing that, as I said, picks up the parameters from the batch script and launches your job across the applications. If you got rid of the srun here and just deleted it and just said xthi, that wouldn't run it in parallel. It would only run one copy on one core. It would run you a serial job, regardless of what you'd put in the batch script, saying, you know, you wanted to run 128 copies per node. It wouldn't do that. Okay. So now, sometimes you may want to underpopulate nodes on ARCHER2 to access more memory or memory bandwidth. Indeed, we see maximum memory bandwidth really when you go down to about 32 MPI processors per node rather than 128. So for some applications, that can be beneficial. The question here, a couple of things for you to play around with here. Can you modify your batch script you've already been playing with to now run on 4 nodes with 64 tasks per node, or 8 nodes with 2 tasks per node, 1 per socket, or on 4 nodes with 32 tasks per node, ensure an even distribution across the 8 NUMA regions on the node. So basically that means 4 nodes, 32 tasks per node, but 32 tasks in groups of 4. Okay. And so what we'd like you to do, or what I'd like you to do now, is just play around with that script, to play around with its different bindings of processes on the node. So this is just processes. We're not playing with the threads at all. We're not changing the num threads, but have a look and see if you can get these different tasks to work. And if you have any questions, let me know. I'll try and remember to unmute my microphone next time.
Adrian?
Yes.
I was wondering about the email. That looks really useful, giving an email when I'm halfway through my wall time. I've just tried it, but I haven't received an email. Oh, there you go. It's an S-batch feature. I see. Okay.
But I mean, that might mean, you know, in fairness, I haven't actually tried it on the 4 cabinet system since we started that up in Angus. So it could be that it's not quite configured properly yet. So try it and see. I think it's an S-batch feature rather than an S-run feature.
Okay.
As in, it will tell you the batch job. So you should be able to do it, but you'd have to do something like hash S-batch type. What is it called? Yeah, mail type equals. And then presumably you'd do something like start when it's started, all those kind of things.
Oh, okay. Yeah, sure.
Let me know if it doesn't work. It'd be interesting to know. It should work.
Yeah. Well, I didn't get it to work, so I tried putting a dot forward to my mail. I wasn't sure where it was going to end up. I looked at mail on Archer and I have none, and there's nothing in my mailbox.
That is a good question, actually. I should check that because there is a question of where. So we have an LDAP, so it may be that it knows your email address from your account, from your safe account, but actually I haven't investigated that. I'll have a play again.
Okay, thanks.
Okay, so just so we don't get too far behind, I'll just go through these examples, which hopefully you've seen. At least being able to play a little bit with 1 or 2 of them. Of course, they're using some things that I haven't told you about, including n tasks per socket. But here the examples are, if you wanted to run on 4 nodes, but with 64 tasks per node, and remember the default was 256 tasks per node, I would just specify number of nodes is 4, number of tasks per node is 64, and that means in total I get 256 tasks altogether across the 4 nodes for each. If I don't specify anything else, I think that will just by default put them all on the first socket of each processor, so all on the first processor in each node, and not using second processors in those nodes. You can also specify how many tasks you want per socket. So here I said 8 nodes, 2 tasks per node, 1 task per socket. That means I'm using 2 things per node, but they're spread out 1 in each processor in the node. And likewise here, 4 nodes, 32 tasks per node, 16 tasks per socket, 4 CPUs per task. In reality, I don't actually need this middle thing, 16 tasks per socket. If I just put 10 tasks per node is 32, and CPUs per task as 4, that will spread it out. So I'm gonna use the first core, and then the 4th core, and then the 8th core, and then the 12th core, all the way up. And that means I'm spreading out my work across the node. And that should give me better performance for most things than if I didn't put in this task per CPUs per task, sorry, and just run 32 things per node. And that would put them all on the first 32 cores of this processor and leave the other ones free, which wastes a bit of the memory bandwidth I have available in the node. It wastes a bit of the fast memory connections that I have. And so you may want to do this just like this because you have applications that need more memory or more memory bandwidth, so you get better performance by underpopulating and not using all the physical cores. In the node, you're paying per node, so it's up to you how you want to use the cores in those nodes. You may also be doing this because you want to do a hybrid code where you run MPI processors and then they spawn some kind of threads, OpenMP threads or something similar, or OpenSHMEM processors and threads underneath those. And that's running in a very similar kind of way, where we can specify number of threads per core, a number of CPUs per task, and number of tasks per node. And then we change the number of OpenMP threads we're using, and that will bind the OpenMP threads to the correct place as well. So not only will it distribute my MPI processes evenly across the cores, it will say each MPI process is going to create 16 OpenMP threads and put them sensibly on the number of cores that it has available to them. So as defined here, each ARCHER2 node is made up of 8 NUMA regions, 4 per socket, with 16 cores in each region. Programs where the tasks on multiple regions are less likely to be efficient. So having something where you have 8 MPI tasks and 16 OpenMP threads is probably as far as you want to go for performance for most programs, most hybrid programs on ARCHER2, just because the way the memory is set up. Or more MPI and less OpenMP than that. So 16 and 8, or 32 and 4, or 64 and 2. So hybrid works pretty well. We can configure that relatively easy through our Slurm batch system, but just be aware that because the way the hardware is set up, going to more than 16 OpenMP threads per process is probably not going to give you the best performance on this system. Before you run a job like this, it's always worth using this XTHI program with an example batch script. You know, you can just do it on a single node if you don't need to run on multiple nodes, just to check that actually it's doing the right thing. And what we want to see is the processes distributed evenly across the cores and the nodes, and then the threads assigned to each process distributed across the cores available to it. So if I can just run an example, the slightly thing about doing this on Archer is that because we've got so many cores per node, and you get quite a lot of output. It's not necessarily easy to read for these kind of things, but if I'll just code up an example here where I say I want to do 4 MPI processes, each with 2 threads. Before I open this up to your scrutiny, let me just check that it works. Otherwise, that will be slightly embarrassing for me. But I can then just, you know, give myself confidence that what I'm asking it to do is sensible. Okay. Right. So here's an example of doing this before I'm running my MPI, my hybrid program. I want to make sure that I'm doing my binding correctly, otherwise I won't get good performance. How do I do that? Well, I can use XTHI and show what I'm doing here. Check what I'm doing here. So here's my example. What I've specified is I want one node, I want 32 CPUs per task. That means on that one node, I'm only going to run 4 tasks. Node, and each task is going to have 2 threads, and I'm binding to cores. And then if I run that, I get this output here, which is going to be slightly confusing. But what we can see here is on node 0, my rank is 0. So this is the first MPI process, and it's got 2 threads, 2 OpenMP threads. And we can see the first OpenMP thread has been bound to the physical cores 0 to 7, the first 8 cores. And the second OpenMP thread has been bound to cores 8 to 15, so the second 8 physical cores on this processor. And they both also have access to this range of cores here, which are the hyperthreads associated with those physical cores. So if it's all getting very confusing, don't worry too much. But as I mentioned earlier, each core can run 2 threads, and the way that these processors number them is all the physical cores are numbered from 0 up to 127. That's the physical cores across the 2 processors. And then the virtual cores, these hyperthreads, are numbered 128 to 255. So you can see here that I've underpopulated. I'm only running 8 MPI processors. Each process has 16 cores assigned to it, and then each thread from that process has 8 of those cores into it to work. And you can see that this should give me good performance. You know, this is spreading my workload across all the cores available. So you hopefully, it's evident, but really all I need to specify is, you know, the number of nodes I want, and then the number of CPUs per task. And that should do me the number of OpenMP threads, and that should do the binding correctly for me. If I wanted to use the hyperthreads, I'm doing this on the fly, so this is probably going to go wrong. I think it's either CPU bind is threads or CPU bind is hardware threads. Let me check the CPU bind. You can see it's quite complicated. CPU bind, lots of things. Yes, CPU bind cores or CPU bind threads. So I've changed that to CPU bind threads. Now I think this is going to, let me make this a little bit clearer in my script because it's a little bit of a messy script. But what I've done is I've commented out the number of tasks I've asked it for. So it's automatically calculating the number of tasks I want. Here I've asked for 32 tasks per node. Sorry, 32 CPUs per task, one node. I'm binding to threads now. So I think that's going to give me, instead of giving me, yeah, it's going to give me 8 things per node, I think. Let's check. I think as opposed to what we had here, I think that it's going to maybe go across the hyperthreads first as well. So instead of going 0 to 7, it might go 0, 1 to 8. Let's have a look. I shouldn't second guess it. Oh, okay, it's not made any noticeable difference there, the CPU binding. Fine. There is another thing you can, we probably don't need to get into much detail, but there is, I think, yeah, so you can also specify this thing called threads per core. You can specify 2 or 1 threads per core, so you can also say thread per core equals 2. Let's see what this one does. Takes a little bit of time to run through a batch schedule, just because the scheduler takes a little bit of time to get started. We haven't got too much stuff running on here at the moment, you can see, but my job is still pending. Let's see what comes out of that. Whilst we wait, what I can do is then continue talking about the batch system. So by default, the input and output from these jobs is provided in a file called slurm jobid.out. You can define output and error file names instead to 1 second. You can define different places to put that out. So you can specify an output file name and an error file name, split those into different places and to give you more sensible output and error file names as well. So you can specify that in the batch options for your job submission. Okay. That's all submitting jobs through the batch system to run at a later date. Sometimes, as I've said, you may want to run an interactive job. The interactive job you may want to submit so you can go directly onto a node and try running these kind of things, or run application from a node and interact with the output. And so we can use this command called salloc to do that. So salloc lets you specify the same kind of things you specify into the batch system: number of nodes, number of tasks per node, CPUs per task, time. And in fact, I need to update this example here because I need to put in that partition and that QoS stuff as well. And what that will do is that goes away and it gives you an allocation. It waits until in the queue for you effectively until you've got your nodes, and then it'll say granted job allocation. And once you've got that, you can then run an srun command from the command line, and that will run that on multiple on the nodes you've specified. So here you can then type your srun from your login node, and it will launch it for you. And we can do that as well to give you interactive access to the system. In reality, that's, if you ask for, you have to wait for that salloc to finish to give you your command back. So let me see if I can do one of these real time so you can see how this works. Let me stop sharing that again and start sharing the screen. So here we're going to do an salloc, and I'm going to copy some of these things directly so I don't have to put them in. Of course, some of these things will be wrong, so at 0.19, and we're going to say partition equals standard QoS equals. You can see it gives me back this prompt which says, hopefully you can see, job allocation 32794. So it submitted it to a batch system for me, and I've got a number. And actually, if I had another window open, I could go and see what I was doing at a queue, and it says job queued and waiting for resources. So now I have to sit here on this terminal and wait for it to allocate those resources. And now we see what's happened is it took a little bit of time, but job allocation has been granted, waiting for resources. Nodes ND 001553 and 001554 are ready for the job. And so that means I've been given 2 nodes back. If I do an SQ, you can see down here, I've got a job which is running in the queue with 2 nodes. But here I'm still on the batch systems. I'm on the login nodes, so I don't actually have access to those nodes. But I can do this srun, and I can then launch commands from here, and they run on the login node. So if I type first name here, if I type first name outside this job, then I would just get the name of the login node. But here you can see it's created me 256, or possibly even more. Let me see how many. 256 versions of this command. And it's printing out the host names of those nodes. So I can run a job directly from here now because I've been allocated these resources. Now these nodes are mine, they're sitting there. If I'm not using them, they're being wasted. If I can use them, do an srun and run a job on it, and I get back here. And I don't know what srun. I can even get a bash shell on the login on the nodes I've been given. And when I'm finished of that interactive job, when it runs out of time, I can just type exit, and it'll tell me salloc relinquishing job allocation 32794. If I have a look in the queue, my job is gone. If I type host name now, I just get the host name back of the login node. So you can see once you've got an salloc, it's set up in this special environment where you can run srun and do host name. It will run that on the resources you've been allocated. Now, in reality, for most of the time, this is not useful for you because your job may take a long time to start, and that means you have to sit at the terminal and wait for it to start before you can get on with anything. However, we do have this short QoS. So actually, if you're only doing 2 nodes and it's less than 20, it's 4 nodes, up to 4 nodes and it's less than 20 minutes, I could use this short QoS. I think it's called short. I also have to use a reservation, so this is a special way of using it. I have to use the QoS is short and the reservation is short. The short way of reservation is actually called. Here we go. It's called short QoS. But if I want to, we have this set up for short jobs. For debugging purposes, we have this short queue. And I can run I can run, sorry, I just noticed Doug's having problems hearing me, unfortunately, but I can run my job here. Now, hopefully, that should run more quickly. Now, yeah, there you go. So we've got a job launch pretty quickly, and you can see these nodes. It's giving me nodes 1 and 2, and I can then run my interactive job there. So the alloc, the interactive stuff is useful for the debug queue, short queue, which lets you run up to 4 nodes for 20 minutes. But to do that, you have to use this QoS equals short, and reservation equals short QoS. And that's very similar to the current Archer system, where there's a short queue, I think. You specify minus q equals short. Away you go. Any questions about any of that? Fine. So that's, there are more things you can do with Slurm, including sort of salloc and srun in a single command thing, so you can actually log directly into nodes as well. Don't need to worry about them too much, but that's the basics of using the batch system. And I think the thing that's important is we're using Slurm. Slurm is pretty simple and pretty similar to PBS to use, but we're configured in a slightly different way. And you need to be careful about specifying how how many number of cores and how many number of tasks per node you want to get the right configuration on ARCHER2. But other than that, it should be pretty straightforward. Okay, finally for today, we have debugging and profiling in Archer. So as well as compiling and submitting jobs, another important aspect and tool is how you debug a job and how you profile a job. So either how do you fix something that's broken, or how do you analyze the performance of your existing codes. And again, this has changed somewhat between Archer and ARCHER2. Yeah, sure, Kevin. If you want, we can take a 10-minute break, and this debugging and profiling practical won't take that long. So if we take a break until 3:50, and then we can get back into debugging and profiling, and if that's okay. And I should be able to do the talking part of it in 10 minutes, and then you can play for the rest of the time. Thank you. Okay. I'll just crack on with the debugging and profiling, if that's okay. So this is not meant to provide you with a detailed understanding of how to do debugging and profiling, but really just introduce the tools that we have on ARCHER2, and these are slightly different to the tools that we have on Archer, and then just give you a chance to play around with them. So the two debugging tools that we have available at the moment, and this may change over time, but this is what's available at the moment, is one's called GDB for HPC. It's a command line tool which is similar to the command line debugger that's been around for a long time, GDB. But you can launch parallel programs, or you can attach to running parallel programs to try and work out what's going wrong. And then there's a valgrind for HPC, which is more designed to look at memory errors and memory leaks in parallel applications. And you can compare these kind of things. Actually, this has gone a little bit wrong here, but VStat and CDB and ATP are not currently available, so I need to take those out of this thing here. So ignore that. Apologies. It's valgrind and GDB for HPC.
Adrian, does that mean STAT and ATP might be available in the future?
Yeah, so they should be, I think, but we haven't quite got them set up on this system at the moment yet. Okay, there's an exercise here for you to run through. I'm just going to let you have a play with it. The idea is to then just try and debug an example application using GDB for HPC. The source code should be available by just copying this command and running it. ARCHER2, remembering we need to be on the work file system for this to work sensibly. Okay, so that said not found, so that means I've got a problem there. 1 second, let me fix this download link. The idea is you download a file and then you compile it, you run it, and here we go. Now we need a blob in there. So this link should work for you. For the mistake there. Updated. This link I've put in the chat should work for you. I say that I've not tried it actually myself, so let me try it myself. Yes, that does work. And then we need to do another command to rename it to something sensible. Run. If you run that wget command and then you run this next command, which is move the file to something sensible, then that should give you the code which you can then run these subsequent commands on here. So compile it, load the module, and then use this to run the program. Okay, so what would be nice to do is if you can take a couple of minutes and just go through this typical using a GDB for HPC to debug the application step by step, and see if you can get this to work by having a look at the code and counting and counting and going through the program. Now we don't have to do all these solutions, it's just so you can see that the GDB for HPC debugger actually works. So spend the next 5-10 minutes doing that, then we'll come back and have a chat about it, and then we can briefly introduce the profiling tools, CreatePat, which is very effectively the same as what we had on Archer. We have on Archer, and so if you're an Archer user, that shouldn't be too new to you. And then we can finish the day. So let me know when you have any problems. I'm sure there will be problems in here, or if you have any questions. And then we will come back in 10 minutes time and finish off the lecture material, and then you can play around with profiling a little bit if you want.
Hi, Adrian. I've got as far as launch $myprog curly brackets 1 and curly brackets space dot .my.exe,
Yeah, that's a bit of a mouthful.
as they say. I get starting application, please wait. Application launch failed. CTI error. CTI launch app barrier unable to determine WLM in use.
Awesome. Let me have a look. I can see somebody else had that problem as well.
Okay, yeah. Actually.
Yep, so this is my fault here. Apologies. I need to. So as usual, the Archer documentation is ARCHER2 documentation is up this code on this rather than me. What we need to do here is add a couple of things before we run that. So exit from the debugger, and then what we want to do is, as Kevin has put into the chat, what we want to do is import some variables first, environment variables here like this. And then when we go to do the actual launch, we need to add in a bit more information. So for example, on the ARCHER2 website is more like this, where we have to add in the partitions and the account codes and these kind of things. So you would need to edit this launch command. So let me do this for myself, and then I can copy in the exact one you want to use. So apologies, yep, this does seem to work. So what it's doing is the debugger is actually doing the Slurm job submission for you like an SL. You have to export this CTI WLM underscore IM PL equals Slurm, and then export CTI launcher name equals srun. And then when you start up it, so you launch where you do GDB for HPC and you get this command prompt debug all, you can then run this specific command here, but change the account code to one that makes sense for you if you're not in the TA004 project. A launch args account equals TA004, partition equals standard, QoS equals standard, ASCII node equals 1 to 8, CPU ASCII equals 1, and that should yes, get you up to a point where you see something like what I have now, hopefully. Let me share my screen again. See, I've done this now, and I've got to a point where I've got waiting for debug services, finalize setup, launch complete, my program initial point is in this place here, and then you should be able to continue the rest of the exercise as outlined on the web page. You should be able to do list, for instance, it says, and that should tell you where you are. And you can do step, and now at line 13 we can see NPI come right back. I can type step, and I can go to we're now at line 15. And I say list, it would say I'm on this line here. I equals count, and I could say print count, print rank. And we can see here, this is the nice thing about the parallel debugger, is it's saying actually, I printed out count here, and it's not been initialized yet because I haven't done that line yet. It's the same everywhere, and it's not sensible value. If I print out rank, it's actually different across all the processes, and the parallel debugger will print me out all the different values of rank across all the processes here. So those are the kind of things that you can do. So if you work through that sheet, apologies for the initial cock up, but hopefully that should work better for you now. So I'm hoping you've all been able to run the GDB debugger or GDB for HPC debugger and run the application in parallel. We won't go through all the way through exactly what was going on there. You can spend a little bit of time on this actually tomorrow if you want to work out exactly what's going on in the program. And actually, it's probably worth not running on the 256 threads that I initially set up for you, but running it down to 2 or 4 or 8 so that you don't have to work through all the processes that are running in there. Yeah, it's a nice little program to play with and to play with the debugger with. What I'll just talk about here now is profiling tools, and then we'll finish up for today. And as I say, if you want to play with the debugger and the profiler in a bit more depth, you can do so after hours or tomorrow during the times available tomorrow. Both are perfectly fine. So on the profiling side, we have CRAPAT. It's likely we may have a couple of other tools in the future, possibly Scholastica and some of the tools like that, or Vampire. At the moment, the one we have installed is the CRAPAT tool set, which is CRAPAT Lite, Reveal, and Apprentice, which all come from Cray and should be familiar to Archer users as well as ARCHER2. We should be able to get this. Then we can actually use CRAPAT Lite to profile an application. It's actually generally installed by default. And so when we compile the application, we can then, in fact, actually no. So the base profiling tools are installed by default, but to enable them, you need to enable this Perf Tools Lite module. So you do a module load before you do any compilation of Perf Tools Lite, and then you just compile your code as normal, and it does some lightweight profile instrumentation for you. So it will take your application and add in some instrumentation stuff, so that we can run our application. And so this is an example here. This N-body code that we downloaded before. And actually, I need to change that because it's slightly wrong. So we extract the N-body code, submit it with a batch script that's in there, and then when we run that batch script, we should get out some performance characteristics. So something that looks like this, where it'll tell you ran on 64 processes, you had this much memory, you had this much I/O, the average process time was this. So that will give you some basic profiling stats, and you can have a look at that one, as I say, using this N-body application. That would be a sensible one to look at because it's small enough to get some profile information out of. We can also look at more in-depth profiling with not the Perf Tools Lite, but Perf Tools. So we download Perf Tools Lite, we load Perf Tools, and then we rebuild our application. And then we use a special program called PatBuild to build a profiled version of our application properly. So we can do PatBuild that, and that will create as a new executable N-body parallel.exe plus pat. That's for the name of it. And then we can run that executable, and that will provide us with an output here, which we can then run through this program called PatReport. And PatReport will then give you a more in-depth profile of where time's been spent. So you can see when this example was run, that around 65% of the runtime is in MPI, either in file operations or send receives, and about 30% of the time is in user code, and most of that's in this function called compute forces multiset. And then you can then have a look at, if you want to look at more in-depth stuff. So you say, okay, this is the routine, which is the one that's expensive, but which lines in that routine, and where can I go and have a look at it to optimize my code, or which functions are called from which routine. So CreatePath has got quite a lot of nice functionality in there, which gives you reasonable profiling things, and then beyond that, you can use CreatePath to build a more in-depth profiler, which will just profile the expensive parts of the application and get even more information out of it. So you can rebuild it here with this pat build and use some special output file which is produced in your normal the profile we've just run, which tells the profiler which things to profile, and that can do it in much more detail and much more highly resolved what's going on there. So CreatePath's got quite nice functionality in it, built in on the Crea systems. It will also do hardware-based profiling, so you can have a look at instructions, cycles, floating point bandwidth, and memory bandwidth as well. But as I say, this is not this is a nice little practical to go through both the CreatePath one and the GDB for HPC, so the debugging one, are two nice little standalone application practicals you can go through to have a look at how you do profiling and debugging on ARCHER2. But we have and will have in the future much more in-depth courses if you're interested in pursuing this a bit further, to look at how you use these performance tools or these debugging tools in a bit more detail. And there's a reasonable amount of documentation on the website which should walk you through some of this. So have a look, have a play around. You can play tomorrow during the free time we have to play the system on the applications, and you can ask any questions as we go along with that. But suffice it to say, the main takeaway from this lesson really is we have debugging tools and we have profiling tools for parallel applications on Archer. The main debugging tool we have at the moment is this GDB for HPC, and the main profiling tool is CreatePath. It's likely we'll have more debugging and profiling tools in the future, but these should be enough to get you up and running, hopefully, with your applications on the system for now. Any questions? If not, then what we'll do is we'll wrap up the day here. And as I say, tomorrow what we'll do is we'll come back and we'll talk a little bit about how to be a good Archer citizen and using safe. So this is not really machine usage per se, as just behavior stuff, but also how do you look up things on the safe website about disk space and account usage, and how do I get access to licensed software and those kind of things. And then how do I get access to Archer if I want this longer term beyond the course. And then there's plenty of time for you to play around with the system, either with an application we give you, which is Chromax, or with your own application tomorrow, and plenty of time to ask questions. So if there's no other questions, thanks for coming along today, and I hope to see you back tomorrow, 10 a.m. And I'm happy to take questions just now, if there is any. Good one, thanks everybody for coming.